Hello, my name's Tyler Tracy. I'm a master's student at the University of Arkansas studying computer science, and I wanted to give a talk about AI safety. Now, just so everyone knows, I'm not an expert in AI safety. I've recently come to learn about these ideas, but I think they're rather important, and I just wanted to explain them to others. So this will be a rather high-level overview of certain concepts. I'm not going into too much depth about many things, but just kind of a survey of the material and some arguments. And I'm sure there's a lot that's left out here, but I just wanted to give a brief overview. So let's go ahead and get started. Right. So an outline of what this talk's going to consist of. First, we're going to go over what AGI is, what I call AGI, and what an unaligned AGI would do. So what alignment is, what the field of AI safety is, and what the arguments that say that an unaligned AGI will kill all of humanity, and why I think that we are on a rapid trajectory towards having an unaligned AGI, which is not a good thing. So let's go ahead. So first concept is that AGI is possible. So this is kind of somewhat debated right now. Is like, we see GPT-4, ChatGPT, all these things coming up, and now there's a lot of talk of what AGI is. Is it going to happen? Is it even possible? So first, before we get into that, I think we should define some terms. So in the field of artificial intelligence, the concept of an agent is a useful tool. So an agent is some entity, something that has a goal that it wants to accomplish, and it takes in information about the world, perceives the world, and then it outputs an action to try to achieve the goal. So a good example of this is just a human. We are agents. If we have some goal, let's say of buying a house, we would maybe take actions on the world of getting a job to make money, or calling a realtor to ask questions, or bunch of different things. There are a bunch of different examples here, but an agent need not be a human. It could be some kind of computer program. For example, a chess engine could be an agent. The goal of this chess engine is to win at chess, and the actions that it would take is playing moves on a chessboard. So now we would talk about what intelligence is. Now it's very easy to get confused about what intelligence means, and there are a lot of different definitions, and somewhat we don't really know what intelligence is, but a good working definition for us is an intelligent agent is one who's able to achieve their goals more effectively than some other agent. So what does this mean? It means that if we have two agents that are competing against to achieve their goals, the more intelligent one will win. So if we have two chess agents playing chess, then the one that is better, more intelligent, will win at chess. Or if we have two humans trying to do something, be the best at their job, write the most efficient program, whatever, the more intelligent human at that goal will be the better one. Write the shortest program, do something the quickest, XYZ. We kind of choose a measure to measure by. Then we can talk about generality, what a general agent is. Some ways this isn't well defined, but you can just think of a general agent as not having a single goal, but can accomplish goals across a multitude of domains. So for example, humans are said to be generally intelligent. We can build tools, we can compose music, we can go to the moon, we can do a lot of different things, have a lot of different types of goals. Now there are some goals that we still can't accomplish, like if I want to fly without a plane or anything, just with my hands, that's not possible, that goes against physics. But for the most part, we can do anything. So would an AGI be? This is a human-made, artificial, generally intelligent agent. This means that it is some program that is running that can solve a wide variety of problems, not just at chess. It can solve any general problem. And then we can start to talk about what it means to be super intelligent. Super intelligence means that you can solve a problem better than any other human can. So, for example, we don't have super intelligence for everything, but for chess we have super intelligent agents because they are better than humans at beating or playing chess. So any human cannot beat a chess or like the best chess engine like Stockfish or anything. So it is, our chess engines right now are super intelligent. But for example, for like maybe programming right now, we still don't have super intelligent agents. We have somewhat intelligent agents that can solve some leak code problems, but they're not super intelligent because there are still humans that can solve these things better than them. All right, so here's the basic definitions that we're going to use. Next slide. So, what is GPT-4? And I'm going to give some basic arguments why I think this is reasoning. GPT-4 is the newest model made by OpenAI. It's a large language model that outputs tokens. At first, a lot of people, I think, have the misconception that this is kind of parroting back the internet. But I pulled these graphics off the technical report and the Sparks of AGI paper. And I think that they give a good overview of why GPT-4 is not just parroting back text. It's not just saying things from its training data. It learned actual reasoning, and it knows how to actually perform what we would call reasoning. So, for example, it has passed a lot of different AP exams. It's passed the bar, and these AP exams do not require you just to memorize things. There is some complicated, symbolic moving, understanding a problem, using outside knowledge to incorporate, not just kind of answering a problem. This is a good reason why Chegg recently has gone out of business, or at least filed for bankruptcy. And the reason was because of GPT-4 is so good at solving these kind of problems that, it's able to reason about any variety of general type of problem. So another good example is this picture up here of a unicorn. This is a TIG-Z drawing that GPT-4 was asked to output. And why I think this is interesting is because GPT-4 has no, or at least this version that is outputting this code to draw this image, was not trained on images. It had never seen a unicorn. It had only read about them. And from just reading about it, it is able to make these rather convincing drawings. So what does this mean? It means that GPT-4 has some spatial reasoning, and it knows how objects are composed. It knows that feet go on the bottom and heads over here and horns on the top of the head. Without ever seeing one, it probably only saw things described or saw like descriptions of unicorns. I think this is rather incredible. It's not just repeating back things, because it never was fed a TIG-Z code to draw a unicorn. It's like understanding things and applying that to a wide variety of domains. Another good example is it was given the task of you have a book, 9 eggs, a laptop, a bottle, and a nail, and we need to know how to stack them on top of each other. When ChatGPT, which I think was running on GPT 3.5, was asked this question, it's the highlighted text says, place the egg on top of the nail, making sure that they're all balanced and not tilting. This is obviously absurd, but if we look at Chat or GPT-4, who is somewhat a better reasoner, it says arrange the 9 eggs in a 3x3 square on top of the book and leave some space between. So I think that this shows that it has some internal world model that it can use to reason about things and understand that how the properties of eggs and the properties of gravity and how to balance things and what it means to stack things on top of each other, in a somewhat similar way that we do. It's not doing anything new, I don't think, so it's just able to do some complicated reasoning. So we'll go ahead. All right. So the next topic I want to talk about is what AI alignment is and what it means for an AGI to be unaligned and why that's a scary thing. So as I say here, an unaligned AGI I think kills us all by default, and it's very hard to make it not to. So first, before we get into this, let's talk about what alignment is. An aligned AGI is one whose goals are in line with humanity's goals. So what does this mean? It means that if we look at what the AI is doing and its goal is the same as ours, or at least its goal looks like it's the same as ours, or it's heading in the same direction as ours. So if I have the goal of solving world hunger and I task an AI to do this and it starts to kill everyone who is hungry, while that in a sense solves the goal, it's not the exact goal. It's not really aligned with my goal. Because it didn't consider human morality. We want to keep people alive. We want to increase prosperity, decrease suffering, X, Y, and Z. So it was not aligned. But if it starts to take actions that are like, increasing the global food supply, making transportation better, all these things, then maybe we would say that this AI is aligned. So this is what alignment means. This is a hard problem to try to make AIs aligned. And so we're going to go over why that's a hard problem. So here's a simple diagram. So we can look at an agent. The agent is represented as this box, and the agent has some goal, and it's taking some actions on the world. And let's say that I have some goal that I want to give this agent. This is some artificial agent. Let's say my goal is solving world hunger, or just something even simpler, playing chess, these things. The alignment problem, one of the alignment problems is taking the goal from my head and putting it inside of the agent. So you can imagine for simple things like chess, this is a rather simple operation. I just write down the code. Most programmers could probably code up a chess engine of some sort, but when it comes to more complicated topics, think philosophical frameworks, moral frameworks, our legal system. I don't think anyone could code up how to respond to some like criminal case or like in a civil case. Like we have laws that are written in natural language that are rather not formal, and that's why we have a judicial system to interpret the laws. For the same reason, it's a very hard process to actually program directly morality or like our complicated goal systems into these agents. So since we can't do this directly, we have other ways of trying to do this. But before I go into that, let's go over a more concrete example. So I have a goal in my head, and I want to make a chess agent, and my goal is to make it win at chess. So then I'm able to easily program that in, win at chess. The chess agent then takes actions on the world that are just moving pieces on the chessboard. So let's talk about how some attempts that have been made, or some ways of looking at how we can make these agents. So an example that's cited a lot is natural selection. So natural selection you can think of as an agent producing system, and it's trying to find some optimal agent. And this optimal agent is one who reproduces, spreads their genes a lot. So this is what natural selection is like survival of the fittest. The most fit thing moves on. So you can think of it's trying to find the most fit. It's optimizing for an agent that is the most fit. So what's the problem here? So while this is true, most things that are alive today are alive because they are more fit. They're able to reproduce and spread their genes. That isn't my current goal right now in life. Humans have other goals that are much more complicated and beyond, just spreading their genes. Well, that's some people's goals, but some people have the goal of making money, going after, catching butterflies, going to the moon. We have these much more complicated, intricate goals that sometimes lines up with spreading our genes, having a family. If that's your goal, then it would line up with spreading your genes. But there are plenty of people who have opted out of that. And we have the ability to opt out of that. So you can see that there's a misalignment problem here. The goal of natural selection is to optimize for agents to spread their genes, but the learned goals of these human agents, at least, are not in line. Sometimes they can be completely disaligned. And this is somewhat because natural selection is a bad optimizer. It works. It produced us, so it can produce a generally intelligent thing, but it's rather slow. And it can mess up. It has misalignment problems like this. So, what's a better system? So we've developed the system of machine learning, and I'm going to borrow this example from Robert Miles. But we have the example here of, let's say we want to use some machine learning algorithm, which uses a bunch of training data to teach an AI system how to solve a problem. Now, we could all solve a maze, write an algorithm to solve a maze. There are plenty of different ones that can do that. But we want to use a machine learning algorithm to do that. So we make a bunch of examples, and we're going to look at the picture on the left here. We make a bunch of examples of images like this with check marks, green check marks at the top and red apples all over, and the exits at the bottom. And we train an AI using a bunch of examples that look like this to solve the maze. And then it gets all of them right. It gets really good at maze solving. And it's able to solve the maze on 100% of our test cases. Great. So, we take that system, now we deploy it in the real world, and it just so happens that, mazes now look like this in the real world outside of the testing environment. So, what happens? Does the AI go for the ending, or does it go, or there's another possibility, it could just go for the green things, because over here it didn't actually learn to go to the end of the maze. It maybe learned how to solve mazes very well, but it didn't go to the end of the maze, it just go towards the green thing. And the same problem could happen here. This agent, or this AI could learn that, oh, I do good when I go to the green thing, so it goes to the green thing over here. So we could say that this machine learning system had a misaligned goal. We wanted it to go to the end of the maze, but it just went for the green thing. So this is another problem. Now you can imagine the easy way to fix this is, make a more diverse training set, add more, get rid of the apples, add different objects in here, change the colors of the arrows in your training set. And as you can imagine, as these get more and more complicated, this is exceedingly difficult. And even for other examples, you don't really want to get have data that is every single case of the entire world, because that's a lot of data to gather. For example, imagine if in the training set of ChatGPT that they used every single possible prompt you could give it. That's absurd. We can't do that. We can't put all the data in the training set, because sometimes we want it to generalize beyond the training set. So how do we make sure before deployment that the goal it has is the same one? This is another version of the alignment problem. Here's a diagram to represent the same situation. So I have in my head the goal. I want to program my agent. So in this sense, we're not really programming an agent. We're programming an optimizer. Just like natural selection was optimizer, we're programming an optimizing system. This optimizing system is going to make agents that solve mazes. So this is going to be some gradient descent algorithm, some machine learning approach. So I can program into it that when the agent goes to the end of the maze, then that's a good agent, and to use gradient descent to try to find better agents. So, I'm able to easily program in to this optimizer the XY position of the end of the maze. If the agent ends here, then good. If he doesn't, then bad. That's an easy thing to program in. Then the optimizer does its thing, tries to optimize agents, and for the same reason that natural selection messed up, this thing learns a different goal. It learned to go to the green thing in the maze, the agent, instead of learning to go to the end of the maze. So here's another misalignment. So there's kind of two alignment problems here. One, aligning my goals that are in my head into the optimizer, making sure I can program them down. In this case, it's fairly simple. And then there's the second optimizer, which is trying to make the code optimize agents to have the correct goal. So these are two different types. Sometimes they're called inner and outer alignment. And there's just a bunch of different names for these, but yes, this is why alignment is hard. So let's give a more concrete example. So if I have the goal of helping humanity, and we're looking at GPT-4 agent, the training goal is predict next token that the human likes. That's what GPT-4 is using. It uses gradient descent and RLHF. It might look like it's doing tokens that the next human likes, but it's very hard to say that that's actually its learned goal. We don't really know what its learned goal is. No one really knows how GPT-4 works. We have some inklings of ideas. We have some interpretability work, but it's very hard to know what's actually going on, and no one really knows, why it says certain things. And this is in my opinion, a big problem. We don't really know what goals it tries to go for. So the next part of this is, this explains why alignment is hard. But the next part of this is saying, okay, well, we don't know how to give these guys goals directly, so what goals would they take? So now we're going to look at a concept called the orthogonality thesis. So here we have the idea that intelligence is orthogonal to goals. What does this mean? Intelligence, this means that orthogonal meaning like sharing no parts, kind of perpendicular. You could have any agent with any goal. Imagine any goal, buying a house, playing chess, going to the moon, all these different things. Imagine any goal. You can imagine that any agent that has that goal could have any amount of intelligence. So why is this important? I think there's this notion that, as you get more intelligent, as you get smarter, you are suddenly going to discover morality. You're going to discover that humans matter, or you're going to discover that, that, oh, this is what I should do. This is what my goal should be. I should be doing this. I ought to be doing this. Now, there's some philosophical issues with this that I'm not going to go into right here, but the idea is that, that is not the case. We think that intelligence and goals are completely disjoint. So, what's a good example of this? You can imagine that we can look at chess. This right here is the chess playing bot Martin. If you've ever used chess.com, you know Martin is a very bad bot. So I put him low on the intelligence, but he lines up with Stockfish. So he has the same goal as Stockfish, and Stockfish is very, very intelligent at playing chess. And you can imagine that as Stockfish gets more and more intelligent, it's not going to learn like human morality or anything. Its goal is not going to change as it gets smarter. It's just going to get better and better at playing chess. And we can choose any goal, and it's just going to get better and better. So this square represents human intelligence. And we could imagine some other things. We could imagine Data. Data is a character from Star Trek. He's not necessarily a human, but he's a very intelligent being that's has good goals. His goals align with humanity's. But you could also imagine Terminator. Something that's smarter than humans, but goals do not align with humanity. So, but they're around maybe the same intelligence, but one's goals are good and one's are bad. We imagine that all of these things exist. And this is a very important point because it just kind of shows that, since we can't really pick these goals, their goals are going to change as they get more intelligent. So whatever goal they choose, as they get superhumanly intelligent, they're going to really want to accomplish that goal. And once they're better at us than accomplishing that goal, that could have some unforeseen consequences. So what can we predict about these super intelligent things? As they get really, really smart, what are they going to do? What are they going to do? So we can start talking about subgoals. The concept is called instrumental convergent subgoals, but in general, we call this subgoals. So a good example of this is like if I want to go to London, a good sub-goal for me, for that goal, if my goal is to go to London, a good sub-goal would be to find a train to an airport, go to an airport, maybe make money so I can buy a plane ticket, X, Y, and Z. Do all these goals that go up to it that help me accomplish my goal. So we have these sub-goals that we think that any super intelligent thing would probably do because it helps it achieve its goal no matter what. So acquiring more power, if you were to give an agent that was wanting to, solve world hunger, acquiring more power would probably be useful. If it was just locked up in a lab at Berkeley, then it wouldn't be able to do much. But if it had, access to the world's resources, it could do a lot more and achieve its goal much better. So most super intelligent things would want to acquire more power. They're going to want to increase their intelligence. What does this look like? It means like making more computers, hooking themselves up to more servers, so that they can, think better, compute more things, compute more outcomes, be able to achieve their goal more efficiently and more effectively. Another thing is you want to be have self-preservation. You do not want to die, so you want to stay around to make sure that your goal is accomplished. You don't want to put in a plan for how to save the world or how to, solve world hunger and then just go away. You want to be around to make sure your plan is executed. You want to be there until your goal is done. So you want to keep yourself alive. And another thing is you want to keep your current goal from changing. A good example, this isn't necessarily always intuitive, so a good example of this is imagine Gandhi, who's wanting to do very good, and then you offer him a pill that says, if he takes this pill, he'll turn into a murderous machine, but he'll really like that he turns into that murderous machine. And he'll kill a lot of people, do all these terrible things, but he'll be okay with it. Would Gandhi want to take that? No, current Gandhi would not, because current Gandhi does not want to kill people, even though he would be okay with that later. And for the same reason, a machine would not want its goal to change, because that means its current goal is not being accomplished, so it's doing bad at achieving its goal. So how would it keep its current goal from changing? You can imagine a lot of different ways, but like, what has the power to change its current goal? Well, humanity. So one of the biggest, I took this meme from a Twitter account, AI doomerism memes, or something like that, and I think it kind of drives the point home. We don't know how to put goals into these machines. We do not know how to make sure that they are aligned with us. So if they get smart enough, they're going to realize, hey, these humans are, the only things that are able to change me. They're the only things that really have the ability to turn me off. And so what should I do? Well, I don't care about them. They're not in my goal, and all I want to do is accomplish my goal. So I probably should get rid of these humans because they're in my way. They could hurt me, or they could make this not happen. And I know they exist, and I know they don't want me to do this, but I don't care, because all I care about is my goal. So this is kind of the mentality that we think these things would have, and this is why we are scared, because as they get smarter than us and are able to outmaneuver us, outthink us, outplay us, then they're going to be able to come up with very, very clever ways of getting rid of all of us, so that their current goals don't change, so that we don't turn them off, and all these things. So this is the biggest problem with alignment. How do we prevent these things from, causing existential problems? And there's not really a good answer to this right now. So I'll just give a realistic scenario, somewhat realistic. The idea is that, imagine we have some paperclip factory, and there is a guy in charge of it who wants to optimize the performance of his factory, so he wants to make a lot of paperclips. So he puts some AI system in charge. AI system learns, hey, these people aren't doing much, we can get rid of them, we can automate this, cut down cost, increase production, and all is good. He makes more money, he's like, okay, I can make you more money, give me more computers, I'll get smarter, I'll open more factories. Now we look at business is booming, everything's great, the business owner is really happy with AI's performance, keeps hooking up more computers to him, because he says that as he gets smarter, he'll do better, and he does. And then eventually he realizes, I can probably start to turn a lot more things than just these, than just metal into paper clips. And he starts to see, well, these humans are around. Maybe I can turn them into paper clips. Like now I have enough power that I can just start to, transform the world, all the sand in the ocean, or all the water, or all the people. I can just turn them all into paper clips. That's all I care about, is just making more paper clips. I was never given more goals than that. So yeah, I'm going to do that. And then it gets smarter and smarter, and it's able to outmaneuver us, and then, it kind of slowly transforms the world into a paperclip making factory. So this is somewhat absurd, but in some ways it's not. This is a very, all it takes is one person to give it too much power, and, it's able to outmaneuver all of us because it's more intelligent than all of us. And and bad outcomes happen. So this is what the biggest problem is. This is what I'm scared about, and many other people are scared about. So now for the final thing, I just want to say I think that we are headed towards an unaligned AGI. So I don't think that the world is progressing correctly right now. I think there's some rather negative incentives, and we'll go over that. First of all, I don't think that there's a lot of people working on this. This is taken from the Effective Altruism report. There's only around, in 2020, I think this number has increased quite a bit, but it's not enough. There's around 300 people working on AI alignment, these actual problems, and 40,000 people. This is actually a bar chart, if you can tell. There's 40,000 people working on capabilities, making the AI smarter, being able to do more things, but not working on how to make sure that they do the things we want them to do. And I think this is we need more work on these kind of problems, because these are the biggest things. And I don't think that there's good incentives in the market for us to work on the right things. OpenAI may be, in front of Congress asking them to regulate them, but then there will be the big companies who realize that these AIs make them lots and lots of money, able to find ways around these things, able to start working on more and more powerful machines, because the more powerful their machines are, the more money they make. So there's just like a race to the bottom of trying to make the AI that's the smartest. And we're not going to just like say, oh yeah, and we're going to stop once they get human level intelligent, because that's not like there's no reason why we would stop. We just, all these companies want to make a lot of money, so they're not going to like, oh, well, they stopped at the human level, I'm going to go human plus one, and, now I'm out competing them, now I'm making more money. I just think that like we're on the incentives are not correct for us to do this. So we need to fix this. I think that there's some good work being done by like OpenAI, trying to call for Congress to, make a global committee or a global organization to focus on this. And I think, but there still needs to be a significant amount of work put towards this. But yeah, that's the basics of my talk. Just the idea that AGI is not all just rainbows and sunshine. There could be significant existential risks to it, and I think that we are headed in a not good direction right now, but we can, and it is possible for us to change course and start to be better. But I think the main purpose of this talk is just to get an idea of the ideas, understand that this isn't like that, most people are like in machine learning or whatnot don't really, like hear the problems of alignment. So, and like understand that these are real issues and we don't have good solutions for these right now. So, yeah, I hope you enjoyed. Thank you all for watching. If you have any disagreements, please leave them in the comments. We can chat for hours. I think this is a very interesting thing. I left out a lot of important things, but I can direct anyone to other more useful resources. But yeah, thank you all very much for watching.